I am so excited to show you today how to integrate Red Hat AMQ Broker with the FIWARE IoT Agent and the OrionLD Context Broker to work with your smart model data. We will send MQTT messages from into the broker and onto the IoT agent, who will update records in the context broker. That's the state of a device over time. Let me show you how to get started. All the GitOps for it you can find in github.com/computate-org/smartabayar-smartvillage. This is where it all is. In OpenShift, and then in these two directories, we're going to run some Ansible scripts and some customized components which have already been installed. Let me show you where. Let me make sure my OpenShift local environment is running with crc start in the terminal. It gives me the address to the console, so I plug this in. Now I'll go to networking, routes, go to the Argo CD namespace, and pull up this route to Argo CD. You can see here that the AMQ broker is running and synced, and MongoDB and Orion-LD and IoT Agent-json. Great. Next, I want to start up something new, like a debug pod for sending MQTT messages, because MQTT is a TCP-based protocol, not a HTTP protocol, so we can't create a route for it and run it locally, because that MQTT message will get lost in the reverse proxy that sets up the route. So you have to have a direct connection within the Kubernetes networking. Let's start up a pod. So I will go to workloads, pods, and change namespaces to FIWARE. Let's show the running pods. You'll see we have a broker, we have IoT Agent-json and MongoDB and Orion-LD. Let's create one more. First, we need to copy the login command so that we can run these commands from the terminal. So now I'm good to go in the terminal. cd into home/.local src smartabayar-smartvillage. And we do OC apply-k for customize. OpenShift, customize, bundles. We'll do the FIWARE debug pod base. So this starts up a debug pod for us. It's just sleeping basically and keeping the pod alive. But now we can run commands. We need to install some packages so we can send with MQTT, starting with yum install-y EPEL release to get the EPEL repositories that has the mosquito command. While that's installing packages, I want to show you some more things. Let's query our context broker to show you that there's no entities in the context broker. So what we do is we curl with a header of FIWARE service, and I give it a service of Ansible_test. And then we do another header for FIWARE service path of slash. And these are just ways to group your devices and keep them separate, these two headers, but they're important to the IoT agent and the context broker. And this is the URL to our Orion-LD Context Broker and the entities. So you'll see that it returned an empty list, so there's nothing in there. Also, let's curl the IoT agent. Let's see, we got an error. That could be because these headers are not defined. So we didn't find anything there. Over here, we've finished installing EPEL. Let's install Mosquito. It's MOSQUITTO. Now I want to split this terminal because we want to do a couple things here. If we look at a different pod, let's pull up the IoT agent pod and look at the logs. You'll see that MQTT let's go ahead and restart this IoT agent because I want to make sure that it's clean. I've been deleting things and recreating them. So let's check the logs here. Authentication failed. Let's run some Ansible to fix the authentication for MongoDB, because I think that's what's wrong here. Ansible playbook, OpenShift, Ansible, IoT agent-json -configure MongoDB. If I run this, it's going to fail because we need to add the OpenShift token to the command. So let me go to my token and paste this in here. And run it again. Now this is configured MongoDB authentication for the IoT agent. Now let's delete this pod and make sure everything's happy. Okay, this looks better. So we'll pull up the raw logs and search for MQTT. You'll see that MQTT client is connected. Very good. And it connected to these queues here. So that's perfect. We are going to access this queue here, /json/ it's the service. Well, let's create these first of all. we need to run some more Ansible. But we don't need this token anymore because we're using different APIs. IoT Agent-json dash Ansible device. No, first we'll create the service group. And if we query the services in the IoT agent, you'll see that it created this service here with this resource and API key. Okay, so it's the API key that we're going to put here, and then let's create a device. It's this Ansible device, a YAML. Oops. I introduced a little bug here. So let me fix this real quick and commit these changes. I'm going to rename that to device. And in here, same thing. That looks better. Okay, excellent. Got that out of the way. Now, let me check if our device is registered in the API. So we run this command to curl the IoT agent devices, and here's our device with this device ID. So that's the other part of this queue, and then /attrs, attributes. Good. We should be good to go. With any luck, we'll get some more logs here. Let's query the context broker because it should have a value in here now. It does. It has a traffic flow observed object called traffic flow observed 1. And it has an intensity value, but it's set to null. Let's go and try to update that. We will run a command in our debug pod. But what I actually want to do is, I want to debug it twice. OC-n FIWARE debug pod / FIWARE -debug pod. Now we have 2 copies of this debug pod. In the first one, I'm going to subscribe to the same topic on the FIWARE broker for MQTT within the cluster on port 1883 /json /wildcard /attrs. And our context broker is doing the same right now. Now what I'll do is let's send a message, because this is our other pod. We have a, oh, we need a yum install -y epl release over here as well. And also install Mosquito. Now we can send this command like a real smart device would, with mosquito_pub-h. And this is the path, the service of the FIWARE broker MQTT that's served up on port 1883, and then the queue or the topic is /JSON/ this is the service API key, and then the device ID at /attrs. And we're going to update the value to be -m. And then we do some JSON here. Intensity will be 123. And go. Let's see. I did something wrong. What did I do wrong? It's going to be, forgot the -t for topic. Okay. I believe we just got an event. Let me curl the entities in the context broker and see, look, there's a value 123. Now to show you that we can update this value, we can change it to 456. We'll do that and curl this one more time. The value is now 456. So this is really cool. Let's take a look at our debug pod. You'll see that the intensity changed from 123 and 456. And we'll do 789. So what does this mean? This is really exciting because we have a multicast message queue that can publish to multiple applications at the same time. So with the same message from a smart device, you can update the context broker and other applications that are subscribed to the same message queue. So that gives you some real cool multiprocessing across your cluster related to smart devices. If you want to track, the context broker will keep track of the latest state of your smart device, but you can set up other applications to record historical values for that smart device at the same time with the same message. So I hope that was really helpful, and we're going to do a lot more regarding smart devices on this channel, so stay tuned, and thanks for watching.